Venturing into the digital field reveals the sophisticated systems in place for storing and processing immense volumes of data each day. As we journey into the heart of the internet, we find that databases are the unsung heroes. They're like the hidden vaults where all the world's digital information is securely stored, managed, and retrieved. These database technologies, like everything else in tech, are constantly evolving. Once upon a time, we had simple file systems. Then came hierarchical and networked databases, and eventually the golden age of relational databases dawned. But the digital world is much like a restless river. It never stops flowing and it never stops changing. As the digital landscape became more complex, our data storage needs evolved too. We started dealing with not just structured data, but also semi-structured and unstructured data. The size of the data grew from megabytes to gigabytes, and now we talk in terms of petabytes and exabytes. In this ever-changing world, two types of databases have emerged as champions, each with its unique strengths. They are the structured, precise SQL databases and the flexible, scalable NoSQL databases. Today, we dive into two giants in this field, SQL and NoSQL databases. Databases come in all shapes and sizes, but the most common are table-based and non-relational. The table-based, or SQL databases, are like a well-organized library. They follow a structured schema, ensuring data consistency, but requiring effort to change. Ideal for complex relationships and data integrity, SQL databases offer precision and order. Think of them as a meticulously kept ledger that keeps track of every transaction. On the other hand, non-relational, or NoSQL databases, are like a bustling marketplace. They offer a dynamic schema, accommodating unstructured data and rapid changes. Catering to dynamic digital demands, NoSQL databases provide flexibility and scalability. They're like a constantly evolving organism, adapting to the environment and growing with it. So in the battle of databases, it's not about which one is superior, it's about what fits the bill. If you need precision and order, SQL is your champion. But if you're looking for flexibility and scalability, NoSQL is the way to go. So SQL excels in precision and order, while NoSQL shines in flexibility and scalability. Scaling and flexibility, two critical factors in the digital world. Now, let's delve into the ways SQL and NoSQL databases address these needs. SQL databases, or structured query language databases, focus on vertical scalability. This means they enhance their existing infrastructure to handle more data, like adding more floors to a building. They're all about precision and order, making them ideal for complex relationships and ensuring data integrity. On the other hand, we have NoSQL databases, or not only SQL databases. These databases take a different approach, emphasizing horizontal scalability. This involves distributing data across multiple servers, like building additional houses in a neighborhood. Their strength lies in their flexibility and adaptability, catering to dynamic digital demands. But remember, the choice between SQL and NoSQL isn't a matter of good or bad. It's about understanding your data's nature, its volume, and your application's needs. SQL strengthens existing infrastructure, while NoSQL spreads out, each handling growth in its own way. Data handling is not just about storage, it's about retrieval and manipulation too. Now let's delve into the nitty-gritty of SQL and NoSQL data handling. SQL, with its structured queries, is all about precision and order. It's like a well-organized library where every book has its place. This makes data retrieval a breeze, but changing the structure, that's a bit more work. On the other hand, NoSQL handles data like a collection of documents. Picture a sprawling workspace with stacks of documents where you can easily add, modify, or remove without worrying about the overall structure. This flexibility allows NoSQL databases to handle unstructured data and adapt rapidly to changes. So, in the grand scheme of data handling, SQL and NoSQL take different paths. SQL offers consistency and precision, while NoSQL gives us flexibility and speed. Different tasks require different tools, and databases are no exception. Let's dive into the ocean of data handling. SQL, with its structured query language, is a maestro at managing transactions. It's like a skilled conductor, ensuring each note, or in our case, data point, plays out in perfect harmony, maintaining data integrity even in complex relationships. On the other side of the spectrum, we have NoSQL. It's more like a jazz musician, improvising and adapting to the rhythm of hierarchical data. NoSQL databases easily manage data stored in key-value pairs, document databases, and wide column stores, providing a level of flexibility that SQL might struggle with. Imagine you're building a house. SQL is like a blueprint, precise and rigid, ensuring every brick aligns perfectly. NoSQL, however, is like building with blocks, where you can easily add, remove, or rearrange pieces, adapting to your changing needs. In the end, choosing between SQL and NoSQL often comes down to understanding your specific data needs. At their core, SQL and NoSQL embody different philosophies in data management. Let's delve into these philosophies: SQL's ACID and NoSQL's CAP. ACID is an acronym that stands for atomicity, consistency, isolation, and durability. These principles are the cornerstone of SQL databases, ensuring reliable and precise data handling. Atomicity guarantees that transactions are treated as a single, indivisible unit. Either all changes in a transaction are committed to the database, or if a failure occurs, none of them are. Consistency ensures that each transaction brings the database from one valid state to another, maintaining the overall integrity of the data. Isolation ensures that concurrent transactions do not interfere with each other, providing each transaction with a snapshot of the database. Finally, durability guarantees that once a transaction is committed, it will remain committed, even in the event of power loss or system failure. On the other hand, NoSQL databases are guided by the CAP theorem, standing for consistency, availability, and partition tolerance. The theorem states that in any distributed data store, only two out of these three properties can be guaranteed at the same time. Consistency in CAP, unlike in ACID, means that all nodes see the same data at the same time. Availability ensures that every request receives a response, regardless of whether it's successful or a failure. Partition tolerance means that the system continues to function even when network partitions occur. These two philosophies, ACID and CAP, shape the functionalities and use cases of SQL and NoSQL databases, respectively. SQL databases, with their ACID principles, are ideal for situations where data integrity and precision are paramount. On the contrary, NoSQL databases, with their CAP theorem, are perfect for systems where availability and fault tolerance take precedence and where data can be more loosely structured. SQL's ACID and NoSQL's CAP, two different paths to managing data. SQL versus NoSQL, a decision typically dictated by the specific requirements of the project. In the domain of data management, SQL and NoSQL systems operate side by side, offering unique features suitable for varied applications. SQL databases shine in their structure and meticulousness, perfect for managing intricate relationships and ensuring the consistency of data. Their structured schema ensures data consistency but requires effort to change, focusing on vertical scalability by enhancing existing infrastructure. On the other hand, NoSQL databases offer flexibility and scalability, catering to the dynamic demands of the digital world. They provide a dynamic schema that accommodates unstructured data and rapid changes, emphasizing horizontal scalability by distributing data across multiple servers. In essence, the choice between SQL and NoSQL boils down to factors like the nature and volume of your data, as well as your application needs. SQL excels in transactional operations and complex queries, while NoSQL shines in handling hierarchical data and large volumes of data. In the end, SQL and NoSQL are just tools. Understanding their strengths and weaknesses helps us choose the right tool for the job. Thank you very much for watching. Please stay tuned for the next video and keep being curious.